Now we welcome everyone to our class today, and we just want to start off our class. We are live on our YouTube for those people who may like to watch us from the YouTube. Now, this will be the first class for our 3 days training program on data management and analysis for beginners class. So I just want to take you through what we call our model objectives. At the end of this training program, you shall be able to understand the following concept. One is the concept of data management, the concept of data quality, the concept of data ethics, sample size calculations, and then variable classification, at the same time variable types. This is going to be our first module of this our program. Then as we our next class will be more about, we begin straight away with the data analysis in SPSS. And one of the things that we want to do, the learning objectives, the participants will be able to accomplish the following at the end of the training program: explain data management concepts and as it pertains to the data life cycle, establish how to compute the right sample size in any survey that you conduct, and how to do adjustment to the various surveys that you will be running, understand how variables are classified, and also how variables, the different variable types that we have. Okay, these are the objectives that we want to accomplish in our today's class. So, well and good. We want now just to move straight to our core content of the class, the core content of the class, and we want to start with the concept of what is data management. Data management is a set of disciplines and techniques used to process, store, and organize data. So the concept of data management is important both for organizations and also for the students who are at a higher level of learning. When you want to do what you call research, you must put into place how you will manage your data. Every organization or student researcher must put in place data management plan for effective administration of your data before you begin your research journey. Okay, well and good. When we think of data in the context of students doing what we call their PhD or master thesis, then the first question which you should come to your mind is, what information do I need? What information do I need? What information do I need to collect from what you call my respondent? And remember, answering this question is central to knowing what are my variables in the study that I want to do. Because remember, you want to put an instrument that will assist you to collect data. How will I collect the data? Will it be through interview, or will it be through what you call the survey questionnaires or direct observation? Or will I adopt what you call a randomized controlled trial? Or will I adopt qualitative comparative analysis? Now, these are techniques that require what you call an expert to be involved in collecting data meant for doing what you call an evaluation. How will I synthesize the data? And what about how I will now report my data? And where will I get the finances that will be enough for me to collect the information that I want to collect from the respondent? These are now the central questions that every researcher must be able to answer. So there are questions dealing with finance or the cost of doing the survey. There are questions dealing with how will the data be collected. There are questions dealing with how will the data be analyzed. Okay, so in my data journey, when I want to begin what you call doing my research, to prepare the journey for your data, key questions need to be addressed for data to be used more effectively. These questions fall under tasks undertaken during what you call your data journey, okay? Ranging from determining the right sample size that you require so that you collect an information that you can do what you call inferential, that is, you can do what you call generalization using the right sample size that you have collected from what you call the respondent. So now, central to my questions are here. Now, first is, what is the sample selection? So I must be able to know how to do correct sample size selection in my procedures. So in this case, the question to be answered in sample selection is it necessary to do a sample, or do I don't need a sample in this case, especially in qualitative studies? Sometimes you may be involved in instances when you are not so much concerned about the sample size. If yes, how do I ensure that my sample is representative? Okay, so think of sample size, sample frame, and sample selection approach that you will adopt so that you collect what you call a representative sample from your survey. Next is the concept of data collection. Which method will I use to collect my data? Is it interview? Is it an observation? Or is it the so-called questionnaire? Do I involve key informants in the group discussion? Will I involve what you call the pre-test or post-test checks in the process of collecting data? These are very central questions for any researcher that wants to do an effective research. Will I do what you call data recording during the process of doing data collection? Who will be involved and what format will I use to take photographs and videography? Data storage. Once I've collected the data, it is very important that I store my data in a safe place. Who will be having the password to where data is being stored? Who is going to be responsible for that data? And then issues with security of that data also come in during the process of doing what you call data storage. And then data collection, who will use what method to group data into logically ordered overview, aggregation, as well as to aid what you call the process of data analysis. Now, data analysis, who will examine the data using which method will be used to do what we call data analysis. And then finally, the feedback process that involves reporting the data set to who and in which format will we adopt to report that my data. So that is one of the issues that we must be able to bring forth. Then why do we expect to do what we call data management? Now, data management is important because it increases the use of my data. It will save me time, increase efficiency, and simplifies your work. Okay, so these are now the reasons why conducting data management is very useful for each and every person who is conducting what you call a research. Okay, let me look at one of the questions that in the chat. Now, the next stage is, how do I arrive at developing a good data management plan? When developing a data management plan, it is necessary to consider the following. What type of data will be produced? Okay, what type of data will be produced? Is it going to be a routine data, especially when I'm doing my surveys? Is it an annual data, or especially for those who are taking what you call monitoring and evaluation? How often will that data be collected from what you call the point where I'm collecting it? Is there a protocol or a code book system in my organization that is supposed to be used for categorizing what you call the categorical variable? Who will be responsible? Who has access and who has all what you call the rights and control over the data? That is in what you call data management plan. For every organization must be able to ensure that a proper data management plan is in place to aid the process of data collection, the process of data storage, and data analysis in every organization. Okay, now what are the guiding principles in data collection? What are the guiding principles in data collection? So now the guiding principles in data collections are the following. We want to collect data, but remember, when you want to collect data, we must be able to collect data in a timely manner, and we don't want to waste what you call the resources, which is money. And therefore, we must be able to put in proper mechanisms in place to ensure that the data collection process is not going to be a waste of time. So how will we be able to ensure that? Number one, keeping things so simple as possible. We don't need to complicate even the process of data collection. Even if at all the process involves a complex way, you need to ensure that you integrate more simple techniques of collecting data that can be easily understood by even the very, very people that were engaging in the process of data collection, especially when I'm supposed to use what we call the research assistant. Then the planning the entire process of data selection, collection, analysis, and use from the start are all throughout we must be able to ensure that the process is valid, reliable, and credible. And finally, we must be able to integrate what you call addressing the ethical concerns during the process of data collection. Okay, so good. So know what are the fundamental questions that we need to ask during the process when we want to collect data. So what information do you need to gather? You must be able to know what information do I need to gather. Now, this is the question that is tying what you call, what are my variables? And do I have enough information pertaining to every variable in my study? Where will you get this information and how will you get it? Where will you collect it? Why is the information needed and what question is the information going to answer? Who will use the information that has been collected and how will that information be analyzed? How will the analysis be used, or who require my data? Okay, so that is the central process in what we call the data management process. So I have a story here that I want to present for you so that you can be able to appreciate the concept of where do I collect my data. Okay, so now this is a story here for a crown. A story is being told about the crown and the pitcher. This is a common story that most of you perhaps have already come across. So many of you know the story of the crown and the pitcher. A crown was very thirsty one day and he came across a pitcher with a little water in it, just as you can see from the what you call our diagram. Okay, but he could not be able to stick the beak until he's able to take that water downstream here. So the crown thought for a moment, and then he decided to look for the way out on what he can be able to do so that he can raise the water levels up to be able to drink this water. So what the crown did is to collect around the pebbles that you can be able to see around here, and he started dropping the pebbles down into the stream. And then he saw as the pebbles were being dropped down, the water continued increasing until the water reached a level where the crown was able to drink and the crown was satisfied. Now, this is a typical scenario of what happens in most of the projects, particularly monitoring and evaluation and encounters, that we need to know which data do we require. And before we answer that question, remember the type of data that we require, especially for the people who are involved in monitoring and evaluation program, we require data around what we call the results chain. We require data along the result chain. And then we are going to use this typical example to demonstrate the concept of result chain using what we call the crown and the pitch, just in the next slide. So now, these are the questions. Now, in analysis of what the crown has simply done, that's like a project, a typical project environment. And in that project, we are supposed now to identify areas that we require to collect data. In this story, what is the crown objective? The objective was to eliminate his task. Remember, that is the main objective. So that is going to be the overall goal, which means we shall be interested in realizing whether the goal was attained. So we shall design questions surrounding goal attainment so that we go and take it to the field and collect from the respondent to assess whether the goal of this particular project that we began was achieved. Number two, what is the activity? Now the activity is actually the actions that the crown needs to do in order to raise the water level up. So this activity in this particular case was dropping the pebble. So we must be able to understand all the activities that we are going to do in order to have what you call the output. So those are, we are going to design questions trying to establish the attainment of activities, whether they were attained in particular time or they were not attained within time and cost time frame. Then what are the inputs? What are now the resources that we required so that we can be able to do this project? Like this crown needed the pebbles, needed the crown, and then the big picture was also needed so that the crown can be able to do what you call the activity or dropping the pebble. Then what are the outputs? The output is the result of an activity. As the pebbles were being dropped, what was happening is the water level began to rise. So the water level rising is simply the output of this particular activity that the crown was engaged in. Then what are the outcomes? The outcomes are now in the medium term. What was the crown able to achieve? Now in this case, the crown was able to drink water. And in the long term, the crown was satisfied and he was able to fulfill what you call the overall objective. So now when we are designing what you call questions in our questionnaire, or we are conducting an interview, our interview will be surrounding along how attainment of activities was done, how attainment of what you call the overall goal was done, how the attainment of what you call the inputs were done, how the attainment of output, and then the outcome at the same time, the overall goal. Now, at what will indicate that perhaps what will indicate what were the clear indicators in this example? The number of pebbles dropped. Actually, the number of pebbles dropped is like now he will simply count the number of pebbles that he has already dropped to raise what you call the water level. What will indicate the water is rising? He will simply watch them, which simply means that we also need to know how we are going to identify at every point in our result chain the attainment, which we call the indicator at every level. So those are the questions that are subsequent down here. Now, when you approach every activity that you are doing in this manner, you will realize that you are going to be very comprehensive in the kind of questions or the kind of information you will be collecting from the respondent. Okay, so that one was only meant for us to demonstrate how will we design our questions that we are going to put to the field so that we collect information on. Now, and therefore, we have talked about the questions will be designed along what we call the research chain. But in the typical project that students do in their master's or the PhD level, there is the question they will collect is going to be designed along what you call the variables of the study. Okay, then we come to the next level where we want to look at what is data ethics. We want to look at ethics in the process, but we are collecting data. So ethics is the principle that guide morally correct behavior. The research you are supposed to undertake must be done through a certain norm. Okay, so and therefore we are so much interested in ensuring that we obey some standards that have been established by our country when we are doing what we call our data collection process. Because if unethical choices are made, then that may damage even what we call the reputation of the people that we were engaged in collecting data. So poor, unwise, or unjust decisions can be made in the process of collecting data. And we want to try as much as possible to avoid, and that's why we are integrating ethical concerns in the process of data collection. Now, when we think about ethics, what are the typical areas where ethics is concerned? Now, when we talk about data ethics, are involved in the following areas. Number one, you must ensure that all participants that you have engaged in collecting data, they have been kept anonymous and confidential as much as possible. If at all you are identifying with the names, then you need to use what you call anonymous names like 1, 2, 3, 4, which no one can be able to trace a particular respondent with the name that is engaged in your study. So that's why we are saying that anonymity and confidentiality are some of the ethical concerns that you must be able to integrate during the process of your data collection. Number two is that group discrimination. You need to try to avoid discriminating your respondent. Okay, you may discriminating respondent by their age, their ethnic tribes, and even their sex. You are not supposed to discriminate, which means the data that you are going to collect from the field must be inclusive of the entire group in that particular target population, so that whatever information that we collect from them is a pure representative of their views. Number three is the technical competence. Under technical competence, you are not supposed to collect or employ a data method or accept work which you know you don't have the technical expertise to do it. You are not allowed to accept any kind of work where you don't have enough technical competence. For instance, the donor may require you to use what we call a randomized control trial in selecting both the control group and the experimental group. Now, if you don't understand how to do it, then at least you require proper training on that kind of methodology before you can be able to accept that particular kind of work. Because remember, your data process of collection and quality must not be compromised during the process of you collecting what you call data. Then the next concern under ethics is the honesty, okay? That wherever you are collecting data, ensure that the information that you have collected is what you are going to present. The honesty is expected during data analysis and also during the data collection process. Ensure that all participants have what you call informed consent during the process of data collection. And if possible, wherever you have what you call conflict of interest, you need to present it and continuously try as much as possible to improve your skills when you are involved in the process of data collection. You need to read, you need to interact, attend several seminars so that you continue to upgrading your skills in the process of you being an effective officer or an effective scientist involved in the process of data collection, okay? So under ethics, we are supposed to observe the following: do no harm, okay? Which means we need to respect the dignity of the respondent, well-being and self-worth of individuals involved in data answering your questionnaire. Do not intentionally or unintentionally harm anyone. And then we are also supposed, we have also talked about what you call the competence level. We are not supposed to accept anyone where we don't have what you call a proper knowledge on how it's supposed to be employed, okay? So that's another area that we wanted just to talk about briefly. Then our third area is calculation of the right sample size for our surveys. Calculations of the right sample size of our survey. This is one of the areas that is giving most of the researchers a very difficult time because it involves some mathematical computations, which are very simple, okay, as you will be looking at. So let's look at how do I arrive at the right sample in my survey, okay? So now sample size determination. Now, what is the sample frame? The sample frame is the total eligible population that you are sampling from. For example, if you are looking at the effect of old age monthly stipend, then sampling frame will be the all members of the population classified as old age, perhaps 70 years and above, and enrolled in that particular program in a particular country are going to be considered as the sample frame. Now, that sample frame is important because it is from the sample frame that we will pick the sample that we will subject to our interviews or to answer for us the questionnaire, and then out from what they have given us, we'll use for reporting purposes. Often when you want to conduct what you call random sampling, it's normally recommended, though it is not compulsory, that you must have all the entire sample frame with you in the first beginning, but it is recommended that you have the entire sample frame with you, okay? So let's look at what you call the sample size. So now, large sample size simply reflect you have more confidence, you will have more confidence in the kind of information that you want to report to us. So in general, the larger your sample size, the more confident you can be in the significance of your findings. However, there is a limit upon which increasing what you call your sample size may only lead to what you call diminishing return, which means you need to work with a right sample size in any type of study that you're conducting. Then number two, quantitative analysis require a larger sample size than qualitative analysis. So quantitative analysis are often used for generalization, but qualitative analysis are not used, or the results are not used, are not generalizable. And therefore, when we are doing what you call quantitative analysis, we are required to have a slightly greater sample size. For instance, you are looking for what you call to answer a question on perhaps how many children who go to approved schools make it in life. Now, you are so much interested in the children who attend what you call the approved school, and then finally they are reformed until they make it in life. Now, in this case, you will require at least a larger sample size so that you can use kind of information to generalize how approved schools are very useful in improving what you call the behavior of children. Now, how do COVID patients isolated feel like? Now, this is a qualitative question. Now, in this case, you may not be required to talk about a very large, you may not conduct interview of several COVID patients that have been isolated. You may be particularly interested in even a sizable number than what they report, what they have given you. You can be able now to give us what you call in report. Okay, information we need when we want to calculate sample size. What are the information that we need? Number one, the margin of error. Now, this margin of error simply means how precise will the data you collect be. Okay, so normally in social sciences, we talk about 5% margin of error. Okay, next is the required confidence level. How certain do you need to be that the results are valid? The confidence level, like in social sciences, we talk about 95% confidence level. Okay, then next we talk about the sample frame. This is like the size. What is the total number of people who might be included in your data collection process? So these are the three fundamental parameters that you require in order to compute your sample size. Then let us go direct into computing sample size right now. Okay. Now, the first scenario that we have here is a case whereby the population upon which we want to collect data is unknown. The population is unknown. So this is the frequent formula that we normally use when the population is unknown, where n is the sample size is equal to z squared times p times q divided by what you call p squared, where n is the sample size, z is the value of the z table, 95% confidence, which normally is 1.96, which means you are supposed to take 1.96, square it, multiply times p, where p is the maximum variability of the population. And when we don't know the variability of the population, we normally estimate what we call 50% of it. So we'll be taking 0.5 times 0.5, because q is 1 minus, it's like 1 minus a p. So if we are going to get 0.5, so it is like 0.5 times 0.5 times 1.96 square. That is at the numerator. Then at the denominator is what you call the margin of error square. So in that case, when you compute this, you are simply going to get your n value, where the population is unknown. Okay. So now we perhaps want to demonstrate with an illustration on how you can arrive at this sample size. For instance, if at all, the only thing that I need now to emphasize is the concept of this variability of 50%. This sometimes it can be referred to as, if we don't know it, then we normally use what we call 50%. So we are going to look for examples of how you can be able to do. Let's move to the second slide. Now, in a case whereby the population is known, then you can use what you call sample size calculator. And we normally adopt even the Rausoft calculator. So when you type what you call the sample size Rausoft calculator in your Google, it will come, and then there is a margin for error, there is a confidence level, all what we have talked about. Then you just insert what you call the population. If, for instance, the population is 2,000 or 20,000, then the software will be able to give you the estimated sample size that you need to involve in your study. So it's become just simple as such. Okay. So you can be able to do what you call take any sample, and then you can be able to compute, and in case of anything, you can be able to still be able to communicate with us. Okay. Then I just want to move to what you call the concept of data quality. Now, what is data quality? What is data quality, and why does it matter so much, especially in most of our studies that we conduct currently? What may happen if data quality goes wrong? And then why are we so much concerned about poor data quality? Okay, so these are some of the issues that we want just to address a bit. So defining data quality, what do we mean when we refer to data quality? Now, you will find that now data quality means the information you collect should be good enough to make what you call analysis and decisions that can be reliable. So when we talk about data quality, we are so much concerned about validity of the data. So in answering the question of validity, did you measure what you actually intended to measure? That's now the concept of validity. Number two is the reliability. Can you collect data of the same quality over time again and the results remain unchanged? So that is the concept of reliability. And then we normally have what you call, like in SPSS, we normally have what you call alpha coefficients to be able to test the validity, the reliability, and the validity at the same time of the data set or the instrument that we are using for data collection. Then completeness. Do you have all the data you need to perform an analysis? Then timeliness. Do you have up-to-date data when you need it? Then confidentiality. Is private information secure in your database so that it cannot be spilled over? And then precision. Does the data have enough detail to present a fair picture? And then integrity. Are the data accurate and free from what you call errors? Now, these are now the domains of data quality. So, if at all you want to integrate quality aspect in your data collection process, then you must be able to ensure that your data meets the standard of validity, it meets the standard of reliability, it meets completeness, consistency, timeliness, confidentiality, and precision, as well as integrity must be the standards upon which you are going to say that my data has met what you call the quality aspect. Okay, so for that. Now, we have just done what you call sample size calculation. Normally, once you have done what you call your sample size calculation, you don't just use the same. You normally talk about estimating non-response in any survey. You must be able to estimate your non-response so that you adjust your sample size upwards. Okay, so now the issues in non-response. What normally bring non-response in my surveys? So now non-response may come as a result of two things. The response rate is often used as a measure of likelihood of non-response bias. So now a respondent may decide not to respond. He may tell you he's busy. That is a non-response. Or the question may be so difficult that the respondent do not know. He will leave it blank. That is non-response. So now, in every survey that we do, it is very hard for you to get 100% response. And therefore, the concept of adjusting your sample size based on non-response is very, very important, so that you know which criteria do we use when we want to do what we call sample size adjustment. Okay, so this session we just want to look at how will we be doing it. So we are saying item non-response. Respondent refuses to answer one or more survey questions. Interviewer, what was your total family income last year? And then, I don't know, my spouse keeps those records. So that's the response that you have found from one of your respondents. It means he has not responded that particular question. Then we also have what we call unit non-response. Respondent refused to take the survey at all. Okay, I don't take the surveys, please do not contact me again. So that is the question that somebody has already given you. So in that particular case, what will happen is that that question has not been responded to. So how do we do adjustment to cater for what we call a non-response? In spite of these strategies that you may employ to collect data, non-response nearly always occur in population surveys that we conduct often, including those of low-income families. A non-response is any sample unit that is eligible for the study but has not participated in answering my question. Failure to match the sample cases with the administrative files used to gather the outcome data. Refusal to participate completely in my survey are all these situations that may crop in to bring what you call non-response. So how do I adjust for non-response? You may use the following expression: final sample size, which means the sample size that you have already calculated either from RiveSoft or you have used that 7 formula, effective sample size divided by 1 minus non-response rate. It means therefore that in order for you to adjust for non-response, you need to have an estimate of non-response. Where do I get the estimate for non-response? Okay, now this one is a matter of estimate, and based on the other studies that have been done in that area, you will study the non-response rate, and then you may pick that as what may be your non-response in that case. Example, the minimum number required in calculating perhaps is 80, and you anticipate a non-response of 20%. That 20% will not participate in this my survey. So what do? I know I have 80 divided by 1 minus 0.2. The 20% is like 0.2, so that one will be 0.8. So this is like 80 divided by 0.8 is 100 units now to participate. Now this is how non-response adjustment is done. It is one in order for you to adjust for non-response, you require what you call to estimate the percentage of non-response. And where you get that information, previous studies will guide you to know the non-response rate in that particular survey that you are conducting. Then you adjust this upwards. It's very important that we adjust our surveys with what you call, that is the exact formula that I'm presenting here. Okay. Then now the next thing that we want to look at is data classification. The next thing that we want to look at is data classification. So statistical computations and analysis normally assume that the variables have a specific levels of measurement. Therefore, classification is very, very important. Now, data analysis, the so-called data analysis that we want to do, normally depends on two things. Two factors are very important in order for us to do an effective data analysis. Number one is the nature of my dependent variable, how the dependent variable has been measured. The subject that I want to measure, how has it been measured? Now, that is one factor that will assist me to be able to do that analysis. The second factor that will assist me to do that analysis is the research design, which research design has been used in the process of collecting data. Now, that also will influence how that analysis is supposed to be done. Okay, so I just want to take you into what you call these variables, how they are classified. So types of variables. So variable classifications are broadly classified into two categories. Number one is the so-called numeric variables, numbers, variables that are measured in numbers. So variables measured in numbers are classified into two domains. Number one is the continuous variable and the discrete variable. Now, continuous variables are the variables that are actually being measured, like temperature, weight, and height. Now, the result of continuous variable are normally to infinity. Like, for instance, your age is a continuous variable. You will find that your age is ever an estimate. You will talk about I'm 27 years or I'm 40 years. But by the time you're talking about your 40 years, you have ignored seconds, you have ignored the number of days. So it cannot arrive at an exact age. So that's why we talk about age is a continuous variable. Temperature is a continuous variable. Weight and height, all these are continuous variable. But when you talk about discrete variable, are the ones that are all counted. They can be counted, like how many children do you have? Okay, I have 3, I have 4, I have 6. Okay, you can't say you have 2.5. So definitely they are counted and the result is in whole number. Now, these type of variables, whether it is discrete or continuous, will influence how that analysis will be done. It is only discrete and continuous that we use what you call, we can be able to use measures of central tendency in describing it, like mean, standard deviation, coefficient of variation. Okay, when the result from this, we can use, when describing it, we can simply use those measures of central tendencies when we are describing continuous variable and discrete variable. Okay, then we have the second category, which we are calling as categorical variable. So these categorical variable are like ordinal variable. So now ordinal variable and ordinal variable are the ones that are ranked. Yeah, so you can simply see the smallest to the highest. Like, for instance, somebody telling you to rank the performance of your government since the new government, your president, since they came into power in a scale of 1 to 10, where 1 means they have not performed and 10 means they have performed exemplary very well. So in that case, that's a ranked response. Another case is trying to classify the income levels of households into low, medium, and high. No, in that case, that is a ranked response. Okay, Likert scale responses are all ranked response. So wherever we're dealing with Likert scale responses, our minds should be fixed that we are dealing with ordinal variable outcome. We are dealing with ordinal outcome variable, and therefore all statistical tools that are pertains to testing for ordinal variable will be applied in that particular case. Then number 2 is the binary, a variable which only take 2 values. For example, male and female, true or false, yes or no, positive or negative. These are we are calling as binary. Now, when a response is binary, which is very common, especially for health sciences, biostatistics, we normally model what we call binary responses. So we will be fixed in moving into analysis that support binary responses. And then finally, we have what we call nominal variable. Now, these are variables that bring what we call identifier. They can identify a particular response. For instance, you talk about serial number that are given to batch numbers in batch processing system. When you go to hospitals, every patient is given what you call a number. That number simply identifies that particular patient. You can't use that number for what you call analysis. We call it an identifier. And when we begin that analysis, identifier usually is the beginning. You identify what you call the particular respondent with a certain specific identifier. For the case of keeping secrecy of that particular respondent, the concept of confidentiality. So we normally use identifier. Another identifier is, like, for instance, the serial number in the notes in the notes that you're using in your currency. That serial number is just used as identifier. It's a nominal variable. Okay. The serial number in terms of when you are admitted in an hotel and then you are given a number. That number is simply to give identifier. It cannot be used for analysis, but we are classifying it as a nominal variable. Now, gender is also a nominal variable that takes the form of either male and female. And also we have types of religion as a nominal variable. Name is a nominal variable. Phone is a nominal variable. Email, all are classified as nominal variable in the data set. So it's very important for me to understand how data is classified for the sake of keying properly every variable in my SPSS, as we shall be looking at just in some few minutes. Okay, so far so good for that. I just want to take you now to variable classification, variable types. So the variable types that we have are 5 types that we have. So the first one is what we call as the dependent variable. This is the subject that is being measured in every study. Most of the universities, what they do is that they expect you to describe this dependent variable under what you call the background of the study. So we start by the main subject is the dependent variable, okay, what we are measuring. And then the independent variable is what we manipulate. When I manipulate the independent variable, there is going to be a change in the dependent variable. So what the researcher is going to manipulate is referred to as the independent variable, okay? Then in between, we normally have what you call moderating variable. So the moderator is like a catalyst, okay? It means in order for the reaction between X and Y, the M is can either increase the reaction or it can decrease the reaction. So the moderator can either enhance, it can either decrease, or it can have no effect onto the relationship between X and Y, which is why X is the independent variable and Y is the dependent variable in that case. Then you also have what you call mediating variable. A mediator is somebody that is like a go-between, okay? Like when there was a post-election violence in this country, Kofi Annan was sent to come and mediate conflict between the 2 warring parties in this country. Now, the Kofi Annan only came as what you call a mediator. It simply means these 2 warring countries, everyone was supposed to go to what you call Kofi Annan before you reach the other party. That's exactly what the mediator is doing in every study. So it means that X must react with the mediator before going to react with Y. So mediator must be present there. It becomes like a link where X must go to mediator first before it can react with Y. So mediator is compulsory in this case. Mediating variable is compulsory that the X must react in order for us to have a relationship. Without mediator, there is going to be no relationship between X and Y. And then the concept of confounding variable, which simply means other factors that may influence the study, which are outside what you call the scope of the study. These are what you're calling as the confounding variable. And when we are going to run what you call multiple linear regression, you will see the effect of confounding variable in that particular study that we'll be doing by looking at what you call the variability in Y variable, which is we are calling as the R square value, the effect of confounder. We shall be able now to examine what you call the confounding variable in every study. So it's very important for you also to understand the variable, because remember, when you have a mediating variable in your study, especially for those people who are doing advanced statistics, the mediating variable, you must be able to test the statistical significant effect of mediating variable, same time mediating variable, and also the confounding variable. You must be able to test whether the confounding variable has a significant effect, so that you can be able to control the confounder during the design stage of your experiment, at the same time during that analysis, by using what you call the convariant and multivariant analysis method and things like that. So these are very, very key areas that you are required to understand in your data process journey. Otherwise, thank you so much. We are just going now to pick questions before we can break for we can break, and then we come back again for what you call we can get your feedback. Now, can we open up for the for your questions? You can now unmute.
Hello, can you hear me? Yes. Thank you for the great section, Mr. Peter.
Yes.
It has been a wonderful experience. Please, my question is on multiple regression. Like, you want to conduct a multiple regression between independent variable that is nominal, like they are nominal and the dependent variable is continuous. Is it possible to conduct multiple regression? For instance, the research is, we want to find
dependent variable is?
Yes, like we want to find the effect of demographic characteristics on company performance.
Yes.
So I'm talking about the demographic characteristics like the company size, the company years of operation. So these ones, they are all nominal variables.
Yes.
So can you do multiple regression between that nominal variable and a continuous variable when you have more than one nominal variables?
Okay, that's a good question. And that's why the essence of data classification is very important. We've said now multiple regression, we normally accept when the outcome variable is, continuous variable, not nominal. When it is nominal, we normally recommend, we have nominal logistic regression can be able to assist you model that kind of function. But when your variable is, the outcome variable that you are measuring is continuous or discrete, then at least it can support a multiple linear regression. And also,
what about the independent variable?
A general agreement on using ordinal measurement to run multiple linear regression, so long as all assumptions have been satisfied. The assumption of linearity, the assumption of normality, homoscedasticity, all have been satisfied, then you are allowed to use what you call Likert scale or ranked responses to run multiple linear regression. But you are not supposed to run multiple linear regression with a nominal outcome variable in your study. That one is fit for you to run directly nominal logit model. That one will fit you very, very well in that kind of study, but not a multiple linear regression.
What about if your independent variable is nominal in nature?
Okay, now when your independent variable is nominal, but so long as the outcome variable, which is the dependent variable, is continuous, so long as the dependent variable is continuous, your study qualifies for multiple linear regression model. So long as you have also satisfied all the conditions for multiple linear regression. And remember, those conditions are called assumptions. They are the ones to be run first before you can be able now to make a decision of the kind of model that you are supposed to run. As we shall be looking at when we begin what we call the analysis. These ones we will be doing practically, and then you will be seeing how we are doing eliminating what we call outlier. We test for an outlier, we test for normality, we test for linearity, we test for homoscedasticity, then we make a decision that we are going to run multiple linear regression. Those ones we are going to learn practically, and you can be able to see them. There's no problem for that. You will be able to see. But so long as now your outcome variable is categorical, if it is binary, if it's binary, it can be binary, or it is ordinal. Ordinal is where we can go in both directions. But often you will find that because of the kind of when we conduct what we call a survey where the population is homogeneous, or we have stratified them, the responses will tend to a particular direction. So it is very difficult for you to use what you call Likert scale and find that normality has been met. So until you transform. So there is what you call data transformation that will assist you be able now to run multiple linear regression with ranked responses. So if you want to use what you call ordinal variable to run multiple linear regression, you cannot forget all methods of doing what you call data transformation, so that you transform your data set in order to meet all the conditions of running multiple linear regression. Okay. Otherwise, you will be expected to run what you call non-parametric statistics all throughout, because you have not met the conditions for parametric statistics.
Okay, sir.
So another question?
Yes,
Thank you very much.
Well done, sir. Please, at what point or rate the no response will not be acceptable for analysis?
Another question? Yes, yes.
Sir.
Adamu, you can ask your question.
Hello.
Hello, sir.
Yes, yes. Welcome.
Hello, sir.
Welcome, sir.
Hello. Good afternoon, sir.
Yes, good afternoon.
My name is Adamu Mamba.
Yes.
My question is, when you are explaining the calculation of sample size,
yes,
you give us the components under the sample size, the population that is unknown. Why under the population that is known, you say we are going to use a Rosoft calculator. What are the components under this Rosoft calculator?
The component under sample under Rosoft.
Yes.
We said the sample size, the components remain the same that we described, and one of it is what we call margin of error, confidence level, and also what we are calling as all what we described under remains the same. What the requirement for calculating sample size? One of it is the margin of error. We need to establish the margin of error. Okay. We also need to know what we call our confidence level. Yes, we need to know our confidence level. So even in Rosoft calculator, like right now, I want you to just type Rosoft calculator in your Google, then it will come, and you will find all what is required there, just margin of error, confidence level, all the requirements for, and then also the sample frame. If at all you have what you call the sample frame, you can fit it there, because in that case, the population is known. The population is known, so you need it there, and that's what you fit into the formula, and then the calculator will generate for you the right sample size that you need to use. But I was saying that once you already arrive at your right sample size, it's normally important for you to adjust that sample size with non-response. So you need to talk about what is the estimated non-response in the field. If at all it is 20%, then you will get, even if it's 350 is the sample size that I calculated, divided by 1 minus 0.2, which means 350 divided by 0.8, so that you can have adjusted sample size with non-response. People you expect may not respond, so that when you go to the field, now there's going to be nothing that you are working with a less than because of non-response. You are simply going to work with the right number of respondents.
Yes, sir. Thank you, sir. Thank you.
So that may be something that perhaps in most of the surveys is recommended that we look at. What about the non-response? And then we adjust it appropriately.
Yes, sir. Thank you.
Any other question?
Yes, I was trying to ask a question now, but my network was having an issue. I was trying to have a question, but my network have an issue. I was trying to ask about yes, a question.
Yes.
About no response. Is there any standard or rate or point that no response data will not be accepted?
The question of low response.
Yes, yes.
Yes.
If there is a low response, maybe below the standard, maybe 80%.
Yes.
Is it going to be acceptable for analysis, or is there any point or any rate that is a standard for no response that will not be used?
Now, that's a good question, because remember, we said that now the right sample size will determine what you call the confidence. The sample size actually affects what you call the confidence that I will have. Large sample simply means I have more confidence in the report that I'm presenting. Then at least when I have a compromised sample size, then definitely it's simply going to affect the confidence that I'm going to have on the result, the so-called type 1 and type 2 error. Yeah. So it's going to affect the confidence that I will have in the result that I'm presenting in my survey. Okay. So, but yes, then for what you call generalization, you need to work with the right sample size. And that's why, in case you expect a low response, then please, can you adjust it appropriately so that it will not affect the exact number that you need to work with? Okay. Have you seen? I'm saying that adjusting the sample size is meant for me not to have that kind of scenario. Any other question?
No.
Yes, sir.
Okay.
Can I ask?
Can we have a small break? Then we come, or we meet tomorrow, or when?
Hello, sir. Hello, sir.
Yes. Yes.
Question, sir.
Yes.
Okay, let me come with this topic so that you give me some example. My name is Ali Alaji Usman.
Yes.
Assuming I have this topic.
Yes.
Impact of social mobilization.
Impact
of social mobilization.
Yes.
On minimizing non-compliance to polio vaccine in Nigeria.
Yes.
Impact of social mobilization.
Yes, the impact
on
of social
minimizing
mobilization.
on minimizing non-compliance to polio vaccine in Nigeria.
Yes.
So can you use that topic and give me additional clarification between dependent and independent variables?
Now,
Hello,
but see, the independent variables and the dependent variables are automatical from the way you have framed the question. You have said impact of social
mobilization, sir.
Social mobilization. That is going to be my independent variable, and then the other one is yes. Yes.
Hello.
So now I'm saying the question that I needed you to ask is, how do you arrive at your right sample size with that kind of study? Now, that kind of study, you are required to establish first what you call the prevalence of polio in that particular area where you want to do the survey. Remember, when I was using what you call the formula of 50%, this is a case whereby I don't know what you call the prevalence rate. Now, most of what you call M and E statistics, you normally provide a data set that give us about the prevalence rate of a certain disease. So that prevalence rate is going to act as my p-value that I was supposed to use to insert into the formula for computation. And then now 1 minus the p will give me now so you will realize that the so-called 0.5 that I was using for where the population is unknown, it is simply reflecting the prevalence. I'm using 50% prevalence. But remember, for cases like polio in a particular zone like in Nigeria, the polio estimate prevalence rate of polio is known. So you use what is already known from even the health data set from the health surveys that have already been conducted over the field in getting the right sample size. Yeah, if you are conducting a study in malaria, the prevalence of malaria in your country is known. So that is what you use. You don't use now 0.5. So you use what you call the prevalence rate of that particular disease. The prevalence of youth contacting HIV/AIDS is known. That's a data set that is already there in the health department. And therefore, I will use that prevalence rate in inserting in my formula to calculate my sample size. So that's something that perhaps most of you were not aware that that my 50% simply is equivalent of what you call the prevalence rate. And in cases where I'm dealing a study like polio, I'm dealing HIV/AIDS, I'm dealing with the COVID in your country, prevalence of COVID in your country is some a statistic that is already known. And therefore, arriving at the right sample size is of the population, of the entire population, is just a matter of taking that prevalence rate into the computation in your formula to arrive at the right sample size. So any other question? Okay, if at all we don't have any question, then at least now our so-called data analysis will be our next in our next class. We shall be begin straight away data analysis, because we have already talked about the basics. So the PowerPoints I will attach the PowerPoint. I will attach the PowerPoint into the YouTube at the same time our WhatsApp group, so that you can be able to access at our PowerPoint. I said
please,
our
what time
class will be running for 3 different times. This one I've taken a slightly only 1 hour because of I wanted to introduce the data analysis right now, but I think we need to have a break so that we can conceptualize on what we have already discussed, because these are basic component or which influences data analysis so much. Like the question that our friend was raising to us, a nominal variable, am I able to run what you call multiple linear regression? No, you don't need to run multiple linear regression with nominal variable. And actually, the best standard is all categorical variable prefer to use what you call frequency and use what you call non-parametric statistics for doing both your test of relationship and test of grouping variable. In that case, when you have what you call categorical response. Exception is there for ordinal, but even in ordinal cases, you'll just find yourself running non-parametric statistics test. Okay, so that is now how data analysis is supposed to be done. That data analysis is so much influenced by the kind of variable that we are collecting, especially with the subject with the dependent variable. We need to look at, is the dependent variable metric or it is a categorical? So when it is like yes and no, then definitely that's going to be, I will run things like binary logistic regression model or probit model will fit well for that kind of study, because, and that's what is so common in surveys that involve health sciences, yeah, where you expect even the result is positive or negative, it's positive or negative, yes. So such kind of responses that take the two values only, we run what you call binary logic models or probit models. They fit very well in modeling such kind of studies. But when we have, where in such cases, we only testing the probability of an independent variable influencing the dependent variable. What is the chance? What is the likelihood chance of independent variable influencing the dependent variable? That's what we are going to test, okay? And when you observe those standards, you will realize that a data analysis becomes easy. It has rules. It is not done haphazardly. It has rules and it has standards that must be observed so that you do it well and you give proper reports. Okay, so that's the knowledge that you require so that we can build on that as we meet next. So thank you so much for attending our free class today.
Please, what time are we reconvening, sir?
Yes?
What time are we reconvening? In an hour's time, in 2 hours' time, or?
Meeting again?
Yes.
Okay, let me communicate in the WhatsApp. We can
Okay.
break and then we communicate. We meet in the next 1 hour's time. We can I think we can meet from 6. We can meet from 6. We break for 1 hour, then we meet at 6, so that we look at the interface of SPSS that we will use for data analysis. But I will bring in a new joining ID. I will bring in a new joining ID.
It's okay, sir. Thank you, sir.
at 6. We shall meet at 6. In 1 hour's time.